So to integrate this function, we're going to use u substitution, where we say let u be equal to natural log of x squared plus 1. The reason why I've picked the x squared plus 1 is that when you differentiate the inside, you are going to get this part here. So it's the best way, it's the best pick. In this case, we are going to say we differentiate our u, we get du, which is equals to differentiation of ln x squared plus 1. We just differentiate the inside, which will be 2x, then we divide it by the inside function, which is x squared plus 1. Normally we also include the ln e, but you know that ln e is going to be 1, so we don't include it. But in terms of logs and these other things, we include it since it has a different base other than e. So since we have it here, we are going to make it dx subject of formula. So we multiply here, we are going to get 2x dx, which is equals to x squared plus 1 du. Okay, we are multiplying everything here. Here you divide by 2x, you divide by 2x, meaning your dx is going to be x squared plus 1 du divided by 2x. Since we have our dx, we can replace into the main function. So we have the integral of the integral from 0 to e to the power negative e minus 1. Here we have a 2x. Then where there is ln x squared d plus 1, we are going to replace it with u over here we have x squared plus 1, then multiplied by our dx. We found it as x squared plus 1 over 2x then du. This 2x and this 2x will cancel out. The x squared plus 1 and x squared plus 1 will also cancel out. What will remain is the integral from 0 to e minus 1 of u du. Here, just like you differentiate another function with a single term, it's going to be equal to u, we add the 1 to the power and subtract by and divide by the new power. So it's going to be u squared over 2 plus c. But we said our u is the ln of x squared plus 1. So we will replace, meaning we are going to have natural log of x squared plus 1, then everything squared over 2 plus c. To this function now, we are going to put the limit, since we have been given the limit that is supposed to be from 0 to root of e minus 1. So we'll put the final limit, which will be natural log of root of e minus 1 squared plus 1, then everything squared here. Then we divide everything by 2, then minus, we put the value for the lower limit, which will be natural log of 0 squared plus 1, everything also over 2. With this, it's the inside here, when you square it, it's going to be natural log of e minus 1. The square root and the square will cancel out, so we'll remain with e minus 1. Then e plus this one outside, it's going to be here plus 1. Then everything we square, so we can just say over 2 here, minus Here we are going to have natural log of 1, since it says 0, over 2. So simplifying it further, we are going to have 1 over 2 open natural log 1 minus 1, we are going to get a 0, so it will be natural log of e squared, then minus natural log of 1 is always a 0 here, so we have a 0. From here we are going to have 1 over 2 natural log of e is simply 1. Natural log of the base e is 1, so 1 squared, it's 1 itself, minus 0, meaning our final answer is simply 1 over 2. This is the integration of the equation with limits.